Broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome to Young Engineers of Today, and welcome to the first of the North Carolina Science Olympiad NCSO classes. I'm Mr. DeToy, joined by Mr. Dubik. We're going to be working together to help you out, and we'll get you.
Hey, folks.
We'll get you familiar with Scratch so that you feel confident with it when the competition comes around, which is also going to involve a fair amount of learning about the fundamentals of programming as well. But don't worry, that's not nearly as scary as it sounds like. So let's see here. I'm just going to give it a couple more minutes to see if anybody else joins.
Gotcha. Tom, do you see your screen there? Because I don't see it here, and it might have been because I started.
I should be showing it now.
Okay. Is it just a Google screen, or does it show Amazing Mechatronics or Scratch?
It's Scratch. Is it Amazing Mechatronics?
No, it's Scratch. You got the right one. No, it's B. It's the same one we just used.
Okay.
I'm gonna see why am I not seeing your screen? Maybe it's just me. Oh, there we go. Here we go. Found it. My bad. Sorry.
No worries. But yeah, we'll give it a few minutes for people to filter in, as is sort of the custom for the first class of the year. Maybe at about 6 or 7 after, we'll get started in full swing.
I'm gonna walk right back out. We've got one student here that I see. I'm also got my students right now here at school working on projects. So I'm gonna step out just for a second.
Okay.
One. Well, Tom, do you think it's time to start?
Yeah, we can go ahead and get started.
Because at least we'll record this, and this may be a little bit quicker because without a lot of students for this one, but we can record them, and then the people that didn't make it tonight, we'll also make sure that everybody knows that this webinar is going on. But we had a lot more sign up for the first one, pro gamers, and for the second one than we did for this one. So maybe that's what it is. I'm not quite sure, but we'll figure it out. And I'm sure we'll get more people coming on as this goes along. My name is Tom Dubik. That's Tom DeToy. We're both very fortunate. We're worked on this Amazing Mechatronics event. This is the second year of it for middle schoolers using Raspberry Pi and Scratch. And in it, Mechatronics involves both programming but also electronics. So we're going to start off doing programming and get you going so everybody's up to scratch. Now, if you say as a middle schooler, you say, hey, I did Scratch in 3rd grade. I did it in 4th grade. I'm older for that now. Folks, Scratch was developed by MIT. Harvard programming students start with Scratch. Let me say it again, Harvard programming students start with Scratch. I teach high schoolers. I've been doing programming for 6 years. Guess what we start with? Scratch. Just to review the fundamentals. So you'll have that. What the event will be on the Science Olympiad event will be, you'll spend 2/3 or so will be programming questions. 1/3 will be programming and electronics questions. So it's a little bit of both. And you're going to get a series of questions, and then you go ahead and answer them off that. But so I really focus attention on what Mr. DeToy is about to teach you regarding Scratch. Okay? Now, well, before we get started any further, Yetchin, do you hear us? Raise your hand if you hear us. Great. I was hoping, I was going to have to repeat myself or everybody hears. All right. Well, Mr. DeToy, I'm going to hand it over to you, and I'm going out in another room and work with the Arduinos to get NeoPixels working. So I'll see you in a little while.
All right, sounds good.
All right. You go ahead and mute me if you would.
All right, let's see here. There we go. Okay, so yeah, like Mr. Dubik was saying, this is going to be the Scratch portion of everything, and you may already be familiar with it. And, you know, sometimes I get a little bit soapboxy, but my intention at the end of this is to get you familiar with why. Not just how, but why. And a lot of times that's something that's missing from learning programming is, how do I do this? Oh, you run this particular thing, or you add this command or something, you know, you add this line of code. But a lot of times the why is missing. Why would we do that? Why would it be beneficial to run this particular command? Why do computers need us to structure loops the way that they do? What makes a computer tick? That kind of thing. So that's what I'm going to be trying to focus on more, which, again, that might mean that initially things move a little bit slower as you go. I get it. A variable, it holds stuff. Great. Let's move on. But hopefully it makes things a little bit more interesting as we move along, and those puzzle pieces all sort of start to fall into place. With that in mind, let's get started. So yeah, we're going to be using Scratch, and that's going to be on MIT's Scratch website. So I'm going to go ahead and copy this and paste it into the chat box so that you've got that, which you probably already do. You probably already got a login. Raise your hand if you've got a login. No? Okay. All right. Well, that's going to make things a little bit easier, I think. So let's see here. Let me just sign up real quick. This is going to be the Scratch page if you're seeing this for the first time. It's going to have a whole just bunch of stuff on it. Basically, everything from featured projects on down is going to be stuff that other people have made. So from that perspective, it makes things a little bit easier to understand what you're looking at. What we're going to sort of concern ourselves with is everything up here. Not to say that anything down here is stuff to be ignored. This is great to look at if you're interested in seeing how other people can make stuff using Scratch, what sort of creativity people can have. And you'd actually be kind of surprised, because one of the sort of genius things about programming is no matter what no matter what the programming challenge is, chances are there are just a billion different ways to do it. There are countless different ways to do it. And almost like no two solutions will be the same, because they're going to have a sort of a fingerprint of their own based on how the person thinks and how they were taught or how they learned, whether it was self-teaching or, you know, with a structured educator type thing. And also, you know, the limitations of the software that they might be using, or the language, the computers, things like that. It's actually pretty remarkable to see the different ways that people can solve a particular programming challenge. Anyway, it's neither here nor there. You can check that out later. For now, what we're going to do is we're going to join Scratch, because that's the first step in order for you to be able to do the Scratch stuff. So go ahead and use a Scratch username. I'm going to throw in a 1 at the end there because mine is already used. Type in a password, and then retype that password. That's because I messed it up. And that's exactly why I retyped the password, because if they didn't have a confirmation, I probably would have messed that up on the second time through. Then you're going to provide your birth month and year. Now, it's important to note that if you are 12 or younger, you are going to need your parents' permission in order to be able to use the software. And really all that means is if you, let's see here, if I put in 2005, April of 2005, it's going to ask for a parent or guardian's email address in order to confirm the account. If you're 13 or older, it'll ask you for your email address in order to confirm the account. That's really the only difference. So if you're 13 or older and you've got your own email address, you're fine. You're good to go. So once that's all said and done, you'll be all joined and signed in. So go ahead, and once that's done, raise your hand. So I know that everybody's all good to go. Apologies, I'm on a work computer, so occasionally you'll see work emails pop up. And while you guys are getting signed up, I'm going to go ahead and grab some water, so I'll be right back. And again, just raise your hand if you finished. All right, excellent. Looks like we're all good to go. So I'm going to sign in so that I'm looking at the same screen you guys are. So this is what you're going to be seeing. It's going to be a little bit different now. If you're following anybody on Scratch, you'll be able to see anything that they've been doing. You'll be able to see the local or new news from Scratch, and then again, you can check out all of the different projects that people have made. But for now, we're going to focus on getting started with our own, so that we can basically get down the basics of how Scratch works. So I'm going to click Create at the top here, and just make sure you're on the home page. Anytime if you're not ever sure you're on the home page, you click on the little Scratch logo here in the upper left-hand corner. Excuse me, and it will always take you to the home page. So we can just click Create, and it'll bring up the Scratch project editor. And here we are. We've got our Scratch dashboard, our Scratch board, I guess. So this is where all the magic is going to happen as far as making something in Scratch. And so with that in mind, let's walk through what all the different things are. So we've got our canvas, we've got our sprites and backdrops, we've got our blocks, our script blocks, with all the different categories therein. We've got our script editor, we've got our costumes, and we got our sounds. But what are all of these things? Well, so our canvas is going to be where everything happens. Anything that we make in Scratch is going to be output here to the canvas. This is where basically this is what our program will look like to anybody who uses our little Scratch program. It's going to be our output, where all the magic happens. Not really where all the magic happens. It's where all the end user stuff happens. Then we've got sprites and backdrops here. So as you'll notice, we've got a cat against a white background. So the backdrop is going to be the white part. So we can always, in this area down here, we can change that backdrop to be, I don't know, a nice seascape, or a stage, or a city, or something like that. So we can change the backdrop so that it looks like something that's more thematically appropriate. And then we got the sprites here. The cat is considered something called a sprite, which is basically just a graphic on the screen. And we can change the sprite, so we can make the cat something else, or we can add new sprites. So we could add other characters to the scene. We could add, whatever. So the sprites allow us to change the different things that are in and on the canvas, whereas the backdrop allows us to change the back of the canvas. So that's those two things do. Then we got the script blocks over here. So the blocks are what, hey Kaiji, just so you're aware, this is going to go up on YouTube, so just in case, you want to catch up on any of this stuff, then that'll be there. So yes, this is our motion block here, our motion category of blocks. However, we've got a bunch of other ones. We've got looks, we've got sound, we've got pen, we've got data, events, controls, sensing, operators, more blocks. But this is kind of like the heart of Scratch. This is what's going to make Scratch programs do what they do. All of these blocks here are, in essence, programming. They're just drag and drop programming as opposed to typing programming. But linking these together in new and unusual ways will allow you to create programs the likes of which the world has never seen. And that's the whole point, is we're meant to sort of experiment with these different things and figure out new ways of sort of structuring programs. Not really like, groundbreaking ways, but I just mean creating new programs without having to worry about like the syntax and stuff like that necessarily. But Scratch works off of a very simple principle. Basically, all you do is you just drag this stuff over here to the script editing area. This big gray square over on the right-hand side is the script editing area where we can drag and drop all of our blocks to, and then snap the blocks together like Lego. When we do that, we can run our program. Snapping these together basically creates a larger script. I just dragged it to the middle in order to get rid of it. Snapping them together creates a larger script, which will then sort of add complexity to our program to make it more like a game or whatever you end up making, an informative video / interactive video, whatever the case may be. You can do all that by basically just dragging and dropping and attaching all of these different blocks. And all of these can be basically categorized into different areas for the different things they do. Motion's going to be all related to the movement of the sprite. Looks are going to be changing how the sprite might look. Sound is going to be making sounds. Pen is going to be drawing things on the screen. Data is going to be, well, numbers and words and stuff like that that you can hold onto and change. Events are going to be things that make other stuff happen, so triggers. In essence, controls are going to be things that make the program do different things based on different states of the program. Sensing is going to be listening for, like mouse and keyboard input and stuff like that. Operators is math, the often feared math, although math really isn't that. And then more blocks is stuff that you can create. You can make your own blocks. But yeah, so these are the different things for Scratch. Now, there are other tabs too, which we're going to check out. For instance, we've got the Costumes tab. Now, the Costumes tab is a basically, it allows you to take these different sprites that we've got here and we can animate them, in essence, or we can make changes to them. So this is the default cat sprite that you saw. As we got a couple of different costumes, which are the same cat sprite, but notice how the cat is kind of like doing something a little bit different here. So we could add a whole bunch of different costumes that are all part of this cat sprite, maybe that make it look like it's walking or something like that, and we can cycle through them and give it an animated walk as opposed to just sort of teleporting forward. Maybe we can change the color of the cat sprite here. Maybe we can change the pose that the cat sprite is in. Maybe we can, whatever. We can change the shape of the cat sprite, stuff like that. That's all going to happen here in the costumes area, where we can affect this sprite as opposed to, like changing what the base sprite is or something like that. Then we got sounds. Sounds, pretty self-explanatory. Sounds are the actual sounds of the program. So if we clicked play down here, there would be a cat meow. I'm not going to do it because I'm wearing a headset right now, and I would just deafen myself. But regardless, you could click play here, and you could hear a cat meow, and then you could reference that sound in the script. As you can see, play sound meow. This is called meow. We called this wibble. We play sound wibble. It's referencing the sounds that we've got in our sounds tab. So you would be able to add or record new sounds. You'd be able to edit this one, so we could delete certain parts of it, or fade in and out, or make it softer or louder, make it completely silent, or you can even reverse the direction of it. So it would this particular one part of it would play backwards, which would be really weird. So you could do stuff like that with the sounds tab, which would allow you to add sounds to your Scratch program. That, by and large, is sort of all the different parts of Scratch. Now, we could take a look at each part in more detail, which we're going to do as we go through this, so that you can get more familiar with Scratch and what all the different parts are. And we're going to do that by creating our first program. It's going to be a real simple program. Really super simple. What we're going to do is we're going to make sure that we got the Scripts tab selected. We're going to select the motion. And we got all of our different motion here. Move 10 steps. Turn clockwise 15 degrees. Turn counterclockwise 15 degrees. Point in direction 90. Point towards mouse pointer. Go to XY. Go to mouse pointer. Glide 1 second. So on and so forth. We're going to use move 10 steps. That's going to be the one that we end up using out of there. So we're just going to drag it out and drop it right here in the script editing area. As you can see, it's just a little block sitting on its own, waiting for some additional commands in order to make it a little bit more interesting. And you can click the green flag here and you can see that nothing happens. The green flag here traditionally just starts the program, just so you're familiar. Anytime you want to start the program, you click the green flag on the canvas. But as it stands, nothing is happening. But that's okay. We're not going to worry about that yet. Next what we're going to do is we're going to go to looks. So we've got move 10 steps. Now maybe we're going to have the cat say hello for 2 seconds. As you can see, that's the first option here. So I'm just going to click and drag it. As you can see, it gets dragged out here as well. And if I move it close to the bottom of the move 10 steps, the bottom of the move 10 steps lights up white to let you know that it's going to snap to it. If I let go, click, there it is right there. So now we got move 10 steps and then say hello for 2 seconds. How do I know it's going in that order? Because Scratch always moves top to bottom. Always, 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 always. Actually kind of amazed that I said always that many times without screwing it up. But it is always going to go in that direction. It's always going to run from top to bottom. I know I'm saying this a lot, but I want to impress upon you that it's always going to go from top to bottom. But yeah, so that is for your edification, for your knowledge, just so you know how Scratch works. So it's pretty straightforward then. It's going to move 10 steps and it's going to say hello for 2 seconds. Click the green flag. Nothing's going to happen. Well then, interesting. That might be because we're missing an event. See, here's the thing. There's this phrase. I used it in my previous class. I'm going to use it in this class. I'm going to use it in my next class. I'm going to impress upon you the importance of this phrase throughout the 3 weeks that we do this, in all 6 sessions. And that phrase is this. And don't forget this phrase. Computers are dumb. They are. Computers are amazingly smart. Computers are way better at math than we could ever hope to be. Computers are amazingly good at keeping track of things and, you know, recalling them with 100% perfect accuracy, much more so than we are. There's even still not 100% accuracy with computers necessarily, but more on that if you ever decide to go for a computer science degree. But they remember things way better than we do. They're able to do math way better than we are. They're able to determine yes and no much more clearly than we can. But on the other hand, computers don't have opinions. They don't know how to do anything unless we tell them how to do something. They don't have the ability to create, complex chains of thought and correlation like we can. We can look at how the moon might hang in the sky differently, and the ocean might come in closer to us and go, hey, it seems like every time the moon gets closer, the tide comes in. And through observation, we can reinforce that, and we can draw parallels with other concepts once we learn them. Oh, hey, gravity is a thing that exists. Oh, you think the moon has gravity? Oh, yeah, the moon has gravity. Maybe the gravity of the moon's pulling on the ocean. So we can take all these different, disparate things that don't seem to make any sense, like the moon and a whole bunch of water that's, 250,000 miles away, and draw a conclusion that the two are related through observation. Computer can't do that. It could go, oh, hey, the ocean's changing. Oh, hey, the moon's changing, but only because we told it to, and it will never, ever, 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 ever be able to go, hey, so maybe the two are related. We can create a program that might look at a a change in the moon's distance and a change in the height of the tide, and give you sort of a ratio between the two. And if we tell it that, hey, if this ratio stays within a certain amount, maybe it makes sense, but we have to tell it to do that. It can't do it on its own. So for that reason, computers are really dumb. Computers cannot do anything unless we tell them to. So upshot of that is, if a computer is doing something that you don't want it to do, double check and make sure that you've broken the steps down for the computer into small enough steps so that it understands, and that you've explained every step along the way, because a lot of times a step that makes sense in our head maybe only makes sense in our head, and maybe we need to actually explain that step more clearly to a computer in order for it to do what we want it to do. Conversely, maybe a step makes perfect sense in our head, but we didn't think it through all the way, and we tell the computer to do it, and the computer faithfully does it, not realizing what we actually intended, and so it does it wrong. This is a bug. If a computer does something unintended, that's a bug. And that's a bug because of human error. Anyway, that's neither here nor there. I just wanted to impress that upon you guys. Programming isn't scary. Programming is just breaking things down into small enough steps that a dumb computer can digest them. That's all it is. Just taking a thing that you want a computer to do and figuring out how to break it down into the smallest steps possible. So anyway, let's continue. So we got move 10 steps and stay hello for 2 seconds. Because the computer doesn't assume anything, it doesn't know to actually run this unless we tell it when to run it. So what we're going to do is we're going to, under the events here, we're going to use this wonderful event here that's when the green flag is clicked. And as you can tell, since Scratch always moves from top to bottom, this is intended to go at the very top of a chain of commands. Notice how it's got the nice rounded top, which means that nothing snaps to the top of this command. So this is meant to go at the top of whatever. So we're going to put it right here. Boop. When green flag is clicked, move 10 steps and say hello for 2 seconds. So if we click the green flag, look at that. Cat just sort of teleported forward a little bit and said hello. 10 steps, in fact. So what exactly does that mean, 10 steps? Well, if we move the mouse over the canvas here, you might notice down here in the lower right-hand side, we've got a couple of X and Y values that keep changing as the cursor moves around over it. These X and Y values, if you've ever worked with graph paper before, are like points on a graph. And they're meant to represent all different parts of the canvas here. I'm doing a terrible job at keeping a nice grid, and I preemptively apologize for that. It is very hard to do this properly with a mouse. But assume that these are all evenly spaced. Oh my goodness. Oh, the humanity. Oh, these lines. Oh no. Okay, assume these are all straight lines that are all parallel and evenly spaced. Where these lines intersect are going to be points. That's where this number comes from, the x240, y88, etc. This allows us to keep track of what is on the screen. Because I might say like, hey, what's this right here? And you might go, what, where? And I go, right here. And you can't tell what I'm pointing at because I'm pointing at the screen with my finger right now. But that doesn't help you at all because you can't see that. Computers can't see that either. So we need some way of keeping track of positions on the screen so that we can tell it to move to certain positions. We can ask what is at a certain position. We can ask it if it is at a certain position, so on and so forth. So we do that with X and Y coordinates. X always represents the horizontal and Y always represents the vertical. So if my cursor is right where it is, for example, it's at X 183 and Y negative 90. You might be saying, like, that's weird. Why negative 90? That's because the center is 0, 0. And I can't, get 100% there because it's just going to be a pain in the... Here we go. There we go. That is the exact center of the canvas. And X and Y are going to be 0 and 0. So as Y goes to the right, it becomes positive. As X goes to the right, it becomes more positive. As Y goes up, it becomes more positive. So if we take X to the right, it becomes positive. If we take Y up, it becomes positive. If we take x to the left, it becomes lower and even more negative. As we take y down, it becomes lower and more negative. So we can have negative values for x and y as well. That's why you might see a negative value for y or a negative value for x, because the center is 0. So when we say move 10 steps, we mean move positive 10 on the x, and that's also because the cat is facing this way. Move forward 10 steps. So if we click the flag, if we click the flag again, we'll see it moves another 10 steps and says hello again. Click it one more time, same deal. Click it one more time, same deal. You get the idea. We can continually move the cat forward this way. We could also, if we really wanted to, I could right-click on this move 10 steps, and as you can see, I get this little contextual menu. I can duplicate it, attach it to the bottom, duplicate it, attach it to the bottom, so on and so forth. So I'd only have to click the flag once, and the cat would continually move. In fact, the cat will move 10 steps 8 times. And then it'll stop. If I want it to move another 8 times, I'll have to click the green flag again, and it'll do it again. You get the idea. What if we wanted the cat to move 50 times, 100 times, 400 times, 500 times? That would take a lot of duplication. But there is an easier way. Let me go over here to control. First thing I'm going to do is I'm going to attach this one block here underneath it, this wait 1 second. And notice how any of these have inside the little white, they're their own little text boxes, so we can change it. So we can have them wait for 2 seconds or 20 seconds or 100 seconds, but we're not going to do that. We're just going to have them wait for 1 second. We can have them say butters, or we can have them say log, or we can have them say open sesame, but we're just going to have them say hello. So we can change the values in there as well to mess around with the different things that we need to have values that work better for us. So now, if we were to click the green flag, he would move 10 steps, he would say hello for 2 seconds, and he would wait for 1 second. Which, this last part at the end, seems kind of useless because we can't see that happen. The hello goes away, but see, the green flag remains for another second before it turns into a red stop sign. But what's the point in that? Well, I'll tell you. I'm going to introduce the forever loop to you. So we got this bracket-looking block here that's labeled forever. And I'm going to mute for a second because I'm about to cough a whole lot. Oh boy. Okay, my throat was really dry there. All right, so yeah, we got this block labeled forever, and it looks a little bit different from all the other blocks we've been dealing with so far. Now, those of you familiar with Scratch probably already know where this is going. Those of you who are not, this one works by slightly different rules than all the ones we've dealt with before. So it snaps to the bottom just like all of them. However, with other ones, if you want to stick it somewhere else, you can move it, say, to the middle, and it will displace anything above it. So basically just shove down the say hello in order to make room for the wait 1 second. If you want to replace it, we'll have to, shuffle everything back to its natural order. But it will always, new blocks will always insert themselves. These work a little bit differently. Notice the sort of the gap between the top and bottom parts of this as you move it up. It expands. It gets larger and larger. Well, that's interesting. If I stick it maybe between the when green flag is clicked and the move 10 steps, it actually encompasses these 3 commands here. That's because what the point of this is it's meant to repeat anything that's inside, that's bracketed by it, that's held by it. So if we were to click play, notice I'm clicking play once, and the cat is moving and saying hello repeatedly. So we haven't broken the rules of Scratch at all. We haven't done anything that's outside of the realm of acceptability for how Scratch is programmed. Scratch is still running from top to bottom. It's still running over and over, or it's still running from top to bottom. So we're going when green flag is clicked, and then we're going, oh, hey, forever. What's inside forever? Move 10 steps, say hello for 2 seconds, wait 1 second. We get to here, and then there's this arrow right here, and this arrow essentially signifies, hey, go back to the top of this forever block and start over again. And so we go back to the top, we move 10 steps, we say hello, wait 1 second, boom, 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 but we're still always moving from top to bottom. We just have this little caveat here, this little weasel, this extra little wrinkle in things, which is the loop. So this loop is labeled forever. As one might imagine, this loop will never stop running. Not at least until you click the red stop sign in order to actually just kill the program itself and get it to stop running. Interesting. So a forever loop runs forever. Now, there are plenty of different kinds of loops. There are loops that are meant to run until a certain condition is true. There are loops that are meant to run unless a certain condition is true. That's the same thing, I just said it twice. Until a certain condition is true, as long as a certain condition is true, meant to run a specific number of times, like 10 times or 300 times or something like that. And then there are ones that are just meant to run forever, like this one right here. So the nice thing about loops is it allows you to take a certain amount of code that you want to repeat over and over and over and over again, and it allows you to repeat it over and over and over and over again an indiscriminate number of times without you having to copy paste the code like a madman over and over again. Or, worst case scenario, type it manually, because that would just be completely absurd. Especially when you start dealing with the forever bit. You can't actually copy and paste forever. That doesn't work like that. So you would eventually have a computer program that just stops running, just closes on its own, unless you used a forever loop. So that's the advantage of these things. It allows you to keep a program running continuously, keep a part of a program running continuously, running a certain number of times, whatever you need. And then finally, we've got the right-click function. I talked a little bit about it just a moment ago. I'm going to cover it again, just all the different functionality bits of it. So if you right-click on something, you get a little context menu. So we've got duplicate, delete, add comments, and help. Help is pretty awesome, actually. If you right-click and select help, it'll give you information about whatever you've got selected. So say words in a speech bubble for a number of seconds. Or wait specified number of seconds, then continues with the next block. Or move a certain number of steps. The sprite will move in the current direction, type in how far you want it to move. The Scratch stage is 480 steps wide and 360 steps tall, so you get an idea. But yeah, so help is very useful in that sense. If you're ever confused as to what something does, you can right-click on a block and select help. Duplicate, pretty self-explanatory. If you right-click on a block and select duplicate, it will duplicate not only that block, but all of the blocks that are connected to it below it. So if I right-click on this move 10 steps and select delete, then I get the move 10 steps and say hello and wait 1 second. If I right-click on the say hello for 2 seconds and wait 1 second, then I get just the say hello for 2 seconds, wait 1 second. If I right-click on the wait 1 second, I just get the wait 1 second. So as you can see, there is a very specific kind of structure to how things are duplicated. It's always the block that you right-click on as well as any blocks below it connected, including any blocks inside. So if I right-click on forever and duplicate, I get another forever block with everything inside of it. Then we've got delete. I'm just going to go ahead and show you. Hey, look at that. I deleted it. Now, in case you ever did this on accident, let me show you this. You go up here to edit in the upper left-hand corner, click on it, drop down, undelete, click on that, boom, it's back. And then you can just replace it, put it back on its rightful throne. So that's very useful. In case you accidentally delete something that you really didn't want to delete, you can always undelete it. Finally, we've got this add comment, which I've kind of been holding off on because I wanted to spend a couple of minutes explaining it. So add comment here. Interesting, I got this little post-it note that's attached to it, and I could be like, Cat is very friendly, so he will say hello, because that's what friendly cats do. And I can minimize it, and I can expand it. Hey, Nicholas. So that seems interesting, although at first glance maybe not necessarily useful. But I'll tell you, it's actually quite useful. And the reason for that is if you guys ever get further into programming, chances are at some point in your life, in your personal or professional life with programming, you will be looking at somebody else's code. And you will really, 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 really hope and wish and want that they wrote their code with comments. Because despite how simple this seems right now, how straightforward this is, you will look at code that you will just have no hope of understanding what is going on. And that is absolutely not meant to be, a remark about your guys' ability. It's just, there are so many different ways to do things with code, and code is in some ways very oblique that it can be impossible to tell what's going on. Especially, often, let me say this. Not only is it not a commentary on your guys' ability, saying chances are you guys won't understand what the other person has written is more a commentary on their ability. Very well written code is supposed to be clear and self-explanatory, but that's not always possible. That's an ideal world. We don't live in an ideal world. So what you do instead is you write comments so you can explain what's going on. So Cat is very friendly, so he will say hello because that's what friendly cats do. Boom. That's why, now you know why that function, why that particular block exists. Was it very helpful on this? No, it wasn't, because this is 5 commands. But if it were 500 commands, if it were 5,000 commands, if it were 50,000 commands, it would be invaluable for maybe explaining why the loop exists. This loop here, this is core loop. Cat will walk forward and then say hello before a brief pause to restart. And then before a brief pause, then restart. Excuse me, I should probably use terminology that makes sense. Now, somebody can look at this and go, hey, okay, cool, that makes sense. So this is what this loop does. And that would be immensely helpful if this loop was 200 commands long. For not only other people, but for yourself. And that's the kicker. Everybody thinks, nobody else is going to look at my code. You're going to look at your code. And you're going to look at your code maybe 6 months from now, or a year from now, or 2 years from now. And if your code is 5,000 commands, as programs can get to be, or 50,000 commands, as programs can get to be, 50,000 lines of code, you might be going like, man, I really wish I commented this, because I have no idea why I did what I did, or how I did what I did, or what I was looking to do there. And this is incomplete. What was this supposed to be? And you'll just be kicking yourself forever and ever and ever. So the whole thing is, you want to make sure that you're making your code readable and understandable for yourself and for other people. Maybe not so important right now when we got 5 commands, but when you got 10,000 times that many, you want to be commenting. So it might not be a bad idea to get into the habit of commenting now, or when you start programming more. Anyway, that's going to do it for today. That was, by and large, where we got with the last class, so that puts everybody on the same level. That's excellent. We will continue with more Scratch, do a couple more programs and stuff like that. We'll actually I think we've got 2 more slideshows for Scratch after this. I'm going to go ahead and do the poll questions right now, so that we can get a feel for sort of how the pacing of the class went and everything like that. If you don't have any input on it, maybe at least try and get something, for what you've seen or something like that. Because I'm going to wait until we get about 60% response, and then I'll start closing down the voting, and then we'll look at the results. And it helps you guys out, because if I went too fast or too slow or something like that, you can let me know now, and I can I can be more helpful for the next time around. I can work at a better speed or whatever the case may be. Anyway, so the first poll questions. All right, we're at 50%, so 5, 4, 3, 2, 1, close. Okay, so the pacing was okay. That's good. And then the next one. All right, so 50%, so 5, 4, 3, 2, 1, close. Okay, so could have done a better job on the explanations. Just so you guys you feel comfortable doing this, if you ever have a question about why I might be doing something or something makes sense, feel free to throw comments or questions into the question box, because I always try and pay attention to that question box, because I want to make sure that you guys know why we're doing something, and that the vote may have just been because I spent a long time on a soapbox about various things. In which case, okay, fair enough. But yeah, no, this is good to know for now. Just please don't feel shy about asking for me to explain something differently or repeat it or anything like that. And then the final one. All right, so 5, 4, 3, 2, 1, close. All right, pretty well split on this one too. Okay, so this is I'm like I said, I'm working from a work computer right now. This will not always be the norm. I will hopefully next time be able to make it home, so that I can use my headset and setup at home. I did a little bit of a sound check before this. I think my headset at home is louder, so you guys might have an easier time hearing me in subsequent classes. However, I can't necessarily guarantee I'm only going to be able to teach from home, so this might happen 1 or 2 more times. So we'll do what we can. I'll try and yell or something. I don't know. But yeah, so that's going to do it for today. If you have any questions, I'm here. Otherwise, you're more than welcome to head out and have a wonderful couple of days, and we'll meet up again on Thursday.